The second stage. In regards to how it functions, the second stage of the regulator is much less complex than the first stage. It is just a simple pressure regulator on demand, which functions with the difference in constant pressure, meaning that it brings the breathing mix from the intermediate pressure to the ambient pressure, making a change equal to a predetermined pressure. The heart of the second stage is the downstream valve. The seal of the downstream valve is created by a seal mounted on the piston, which is pushed by a spring against the seat. By breathing, we lower a membrane, which activates a lever which then pushes the piston away from the seat and allows the breathing gas to pass through. Once inhalation has stopped, the membrane returns in position and the spring pushes the piston back against the seat, closing the flow of breathing gas. Balanced valves can also be used in the second stage. Using a balanced valve means that the force of the spring can be greatly reduced and consequently breathing requires less initial effort. As well as the balancing of the piston, with time a second stage with an adjustable flow which acts on the compression of the spring has also proven useful. If the calibration is optimal, on the surface the second stage of the regulator should go into free flow with the adjusting knob unscrewed and stop when the knob is almost completely closed. In this way, as you descend, you can unscrew the knob and reduce inspiratory resistance to as little as possible. As you ascend, you can begin closing the knob to stop the tendency that the second stage has to free flow. We speak about initial respiratory force to indicate the effort needed to open the valve of the second stage. The subsequent force, inspiratory force, needed to keep the valve open is always less than the initial effort required, also due to the laminar airflow which opposes the closure of the piston. The fluid dynamic effect Venturi, or a dragging or ejector effect, is much more effective. By directing the flow of air into the mouthpiece, we obtain downstream a pressure just a little greater than the ambient pressure, and upstream, in the casing of the second stage, a slight depression. This depression helps to keep the membrane lowered. In this way, the inspiratory effort can be reduced to zero. With some of the early Venturi models, any slight accidental maneuver was enough to trigger a free flow. To reduce this effect, manufacturers invented depression limiters, which introduced obstacles along the route of the gas flow. An alternative solution is to use an external bypass tube. In practice, the air passes from the second stage valve directly to the mouthpiece by means of a small auxiliary bypass tube, keeping the chamber of the second stage almost completely in depression and greatly reducing the respiratory effort. Still with the purpose of reducing the respiratory effort to the minimum, an element commonly used in mechanics has been applied to regulators: servo assistance, meaning a mechanism that is able to carry out a given function after receiving a particular command. With the servo-assisted second stage, the depression created by our inspiration uses the same air at intermediate pressure to open the valve. In simple terms, we can say that instead of opening the valve of the second stage, our initial respiratory effort serves to open a very small valve. In this way, the initial effort is reduced to as little as possible.